Let's see if this clicker works here. That's a good start. So a little bit about myself. I work for a security vendor as a researcher focused on the cloud. And it's funny, I was just talking with Brian, the previous speaker. We're solving a lot of the same problems that his company is solving at Red Canary. And so dealing with the control plane logs, figuring out how to allow people to hunt across that data, because it's not as easy as you may initially think. I also organize here locally for B-Sides Boulder. I think legally, anytime I'm in front of more than 10 people, I have to wear this shirt. So coming up in June, I think we're a little less than a year out. We'll be organizing that. And then last but not least, I do teach for SANS 541, which was just renamed to Cloud Threat Detection. And so awesome class. I am a little bit biased. With that said, let's kind of scope this talk, set expectations. So we are talking about identity in this talk, but we're not going to be talking about hooking AWS to an on-prem AD or a lot of third-party identity providers. We're also not going to be talking about AWS Cognito, which is a way to pass identities to your clients. SAML authentication is off the table, as well as identity pivots using host and network logs. I know there's a lot of methodologies to track actor movement in that space, but we're just not going to talk about it today. What we are going to talk about, though, is specifically looking at CloudTrail logs. So imagine that you're an MSSP, you're getting these logs from your clients. We're trying to figure out how we track this. So let's set aside a lot of the inventorying that you can do. There's some great solutions out there by querying existing configurations. But what we're looking at is just looking at those logs coming across the wire. We're going to look at traditional IAM service, as well as previously known as SSO. It's now known as IAM Identity Service. Here's our agenda for the talk. We're going to briefly discuss why identity is important. If you're at a cloud summit, I imagine you know that's a big part of identity, but also kind of explain the problem that we're trying to solve. We're then going to pivot, speak briefly about IAM users. This is where most people's familiarity with AWS identities lie, so we'll touch on that. We'll look at federation tokens, roles. We'll wrap everything up with IAM Identity Center, because it's a little bit of a different beast in terms of how to track identities in that space. And then finally, we'll summarize it. So in AWS, permissions are king. You can't do anything without a set of permissions. And it's pretty simple. You have policies. Those policies either allow or deny things. And if I have a policy like I have here that says list users, sure, I can run that API call. But if I try anything else, I get rejected. That's the general premise. It gets a lot more complicated, but that's the general premise. And so when I talk about identities, I view identities as a vessel for these policies. So it doesn't matter if you're a user, it doesn't matter if you have a set of access keys, maybe you're even running an instance that has a set of permissions assigned through a role. All of these meets the end goal of being able to make API calls. So there's a few reasons that adversaries move between these identities. The first one is permission or privilege escalation. So I have a lower set of permissions. I would like to do those API calls over there, but I can't. I switch identities and now I can. The second one is detection avoidance. Makes it harder to track identities, harder to track an adversary if they're switching identities. And especially if you have a 4-person security team or a 2-person security team, like you can't, like your incident responders / blue teamers / red teamers / compliance people may not be able to track those identities. And so either one of these, though, leaves traces. So in a perfect world, adversaries would just use the same IP as they're touching multiple identities, and we'd be able to track them just by looking at this IP address. Very, very easy, and this is traditionally would work just fine. But as adversaries can pivot through identity or through IP addresses, we start breaking this chain down. And so now all of a sudden, they're using this user over here, this set of access keys, and maybe a third user over here, and they all have different IP addresses. And so we lose that ability to track them that way. So we set that aside. How else can we track that? Well, there's going to be a chain of events that happen that pivot between these identities. And luckily, this chain leaves logs. So this talk is going to talk about what logs you can track in your environment to look at these pivots between identities. And there's a bunch of different ways to do it. This is not a comprehensive talk either. There's some I certainly missed with SAML and some other services, but this is a good primer and hopefully pushes your knowledge in that direction a little bit. Now, before we dive into this, I just want to say, the methods I'm going to show here are contingent upon your adversary having proper permissions. So I don't want anyone going home saying, oh my God, I saw these things, and if an adversary gets a set of access keys, they can do all this stuff. It's governed by the same rules that we always do for AWS. Either your policy allows it or it doesn't. Next up, I'm gonna have a lot of information on the screen, so I just wanna give a quick primer. Anytime you see something in orange, that is an AWS event name. It's a great thing to grab, take back, and look for in your cloud logs. In the white, we'll have CloudTrail logs, the output itself, and I'll highlight some things in there. If you see anything kind of highlighted in red, that's usually an input or an output of a CLI command. So with this said, as I go through here, you may want to take pictures, you're more than welcome to. At the very end, I'll have a slide with all of the API calls I discussed in this talk. Also post these on LinkedIn afterwards. I think Sans is gonna make this recording available. So you've got a few options. With that said, let's dive into our first classification here. So IAM users. The one that comes to mind if I'm gonna switch an identity is creating another user. This is kind of bare bones, base level. And the one thing I wanna point out on this slide is that you'll notice that this event source comes from the IAM service. That's important because we're gonna talk about another create user later on in the talk that is gonna come from a different service. And so as you're building detections, you'll have to take that into account. You'll have some conflicts between event names. With that said, I can create a user, and that's great. That user has no permissions. That user cannot be logged into. That user doesn't have access keys. So while this is important, this does not indicate that somebody moved from one identity to another. We have two methods for authenticating with a user. We have access keys. So that first one up there is create access key. We'll talk about that in just a second. The second one is a login profile. This gives a username and password to allow somebody to authenticate to the AWS console. So if you see these, this can indicate a pivot from one to the other. Creating access keys is pretty straightforward. You run the API for create access key and you specify a user. One of two things will happen. One of three things will happen. One, you won't have permissions to do that. Two, you'll have permissions, but the user you're specifying already has two access keys, so it'll get rejected. Or three, you'll get the output you see up here, which is a access key and a secret access key. These are long-term credentials. They do not expire. And if you see an adversary moving in this direction, you can track it using that access key ID up there. The other option we have is creating a login profile. Now, this works a little bit differently. Whether you just created a brand new user or you have a user that already exists, it may change the way you approach this, but either you can create or update a login profile. And essentially, you put the password in, and you say no password reset required, and it'll reset that password to whatever you just specified. And so the follow-on activity from this would be a sign and log. So far, nothing crazy. Last thing I'll say is if you create this user, you give it an authentication, you log in, you're gonna get a bunch of sad red X's in the console. And that's mainly because there's no policy associated with it. So you would have to see an attachment of a policy or adding that user to a group. Let's move on to something a little bit more interesting though. Federation tokens. By show of hands in the audience, how many of your organizations use federation tokens? 1, 2, 3, 4, let's say a dozen. I got lights in my eyes, we'll say a dozen. Not many, well, I'll just say. So keep an eye out for this. The idea behind a federation token is that I have a centralized application and I have distributed or proxy applications in my environment that maybe I don't want to have full long-lived credentials. And so I can take a set of access keys and I can create federation tokens for these individual applications. That's how it should work. If an adversary gets a hold of the ability to create this, a few things happen. One, they run get federation token, which looking at that API call, I can tell you, I did not expect that was gonna be a creation. That very much reads to me like it's a read-only activity, but that's not what's happening here. They're creating a federation token. A few things you need to specify. You need to specify a name. That name is just a string. You can name it whatever you want. You can name it Sans Cloud Summit. The next thing you need to specify is a policy arm. And we'll touch on this in a second, but you can specify whatever policy you want. In this case, the adversary is being ambitious. They want to give full admin rights. And the result ends up with a 3-piece set of access tokens that are temporary. They're not going to be long-lived. You'll notice in that ARN, though, the following activity after this, if anybody uses those access keys, it's going to look like it comes from this ARN, this federated user / temp user. So whatever name you put in there, it'll look like it's coming from there. That gives the attacker an opportunity to act, and maybe for those less experienced with these types of activities, as a second user. You say, oh, that's our admin doing things. That's fine. If you're not careful, you can fall into that trap. So with federation tokens, there are a few rules with it. They come with a set of rules. First of all, you cannot grant permissions exceeding what you currently have. So if I have the ability to get federation tokens and list users, and I say, I'm going to give this new set of tokens full access. AWS kind of runs a diff on that and says, yeah, you don't really have the power to do that. So not quite as scary as we originally thought. The other thing I'll say is that they exist for a default of 12 hours. So they are short-lived, so it's not a long-term solution for the adversary. Last but not least, there are some restrictions on what type of API calls it can make. AWS knows that this is typically used for an application, probably not something you want managing your users, so there's some restrictions around that. All right. Moving on to roles. Roles is a fun one. I have a fun analogy for roles. I think of an AWS role as a hat. And this hat has special powers. It gives you the ability to run certain API calls, and not everyone can wear that hat, though. That hat, if you look on the inside of the hat, there's a list of users that can actually wear that hat, or a list of other roles that can wear that hat. And if you're not on that list, you don't get to wear that hat. And so nobody is authenticating directly into a role. They're authenticating into a user, and if their name is on the list, they can put that hat on. The only thing I want to point out here is that you'll notice that in this policy here, it's called either a trusted entity policy or an assume role policy. I have three different users on there from 2 different AWS accounts. And so not only can I allow users on my own environment to wear that hat, I can allow third parties. And this is how a lot of vendors interact. So for instance, if a vendor wants to view your logs or touch part of your infrastructure, you're likely not going to create a user for them. You'll likely create a role and give them the ability to wear that hat. So there is an option, an API call where you can update this policy. So you can say, I'm going to change who can wear this hat. And the formatting of this log is pretty gross, I'm not going to lie. It's string formatted JSON, but most SIEMs should be able to process this. And an easy detection right away is to use regex to parse out that AWS account ID and kind of baseline who you expect to be assuming roles in your environment. Now, this is just kind of opening the door. The attacker hasn't walked through. They have not changed identities at this point yet. They've just set the stage. There are 2 different ways that an adversary can wear this hat or kind of assume this role. The first one is through the GUI. In the top right of your AWS console, you can click on your username. All the way down at the bottom is an option to switch role. At this point, it'll take you to a screen that you see there in the middle in white. You can specify the account ID and the role name. If you get those right, and if you're allowed to kind of wear that hat, you'll then move on to that third screen on the far right. And that's going to show that, hey, I'm acting as this role. In this case, it's IAM limited within this account. And then at the very bottom, it shows, hey, here's who you signed in as. And so what's interesting about this is the log that generates is exactly what you would expect. It's an assumed role. The ARN that results out of this, any follow-on activity after switching that role, it'll all come from this assumed role, IAM limited / hackerman. That checks out. That's the user I first had. That's the role that I assumed. Everything is fine. That's pretty easy to track. But there's a second way to assume a role. And because of the way the first one works, this one, it can be a little bit deceptive. When I do this from the command line instead of the GUI, I use assume role. So it's a different event name. I specify the role that I want to assume, and then I specify a role session name. This works very similar to that name field in federated tokens. What's happening here is I can specify whatever I want. This can be any string. And so what a lot of vendors do is they'll put a timestamp or some unique identifier that allows them to track that session over time. As an adversary, I can put whatever I want in there. And so I can specify an existing user. And if you don't catch the switch role or assume role, remember, if we go back one slide, it may be really easy for me to assume that whatever is in that last slash, instead of hackerman, whatever's in that last slash would be the user. That's not the case here. An adversary can put whatever they want in. And so this is another good pivot point to track from one identity to another. Just to be full transparency here, I made that assumption when I started working in cloud, and I learned that was a mistake within the last year. So be careful with the assumptions you make, because I always assumed it worked the same way as switch role, and it just simply doesn't. All right, a little bit about the CloudTrail results from an assume role. If you assume a role within your same AWS account, the CloudTrail gives you all kinds of information about who did that. We see up here in the purple box, we get the username, we get the access key ID, we get all kinds of bits of information, and it's really great. You'll notice in here that the user type that did this, so it's under user identity type, is IAM user. So that's how you know it came from within your environment. If it comes from cross-account, if somebody's reaching into your environment to wear a hat, maybe a backdoor they installed, it'll come from user identity type AWS account. This is another great detection opportunity for you. You should go back to your environments if you don't already have something like this configured. Go filter for user identity.type AWS account. Pull all those back and get the account ID out of that as well. And understand all the AWS accounts that are touching your account. You're gonna find AWS service accounts that are owned by Amazon. You're gonna find vendors. You're gonna find other AWS accounts within your own organization. Hopefully you'll be able to run all those down. I can put it in Slack later. There's a good list that somebody's maintaining of known AWS accounts. And so you can build a set of trusted ones and then let me know if a new one pops up. We built this for a client a while back, and within a week of doing it, we caught another segment of their organization testing out 2 security vendors. I think it was Wiz and Dig Security popped up, and it's working exactly as I expected to, so. This brings us to IAM Identity Center. I'll do another show of hands here. How many people are using SSO or IAM Identity Center, that AWS service? All right, I would say about a dozen. Again, I'm gonna go a little bit conservative here. About a dozen. This is the preferred way to create users in AWS, according to Amazon. So if I say these things interchangeably, IAM Identity Center and SSO, I'll probably lean on SSO because it's less of a tongue twister. It's easier to say, it fits on slides better, but they're the same service. And you'll see some remnants of that change. About 2 years ago, they said, we're gonna stop using SSO as the name of our service. That's confusing. And we're gonna use IAM Identity Center. But there's still traces of that in all their logging. So we'll see that as we view some CloudTrail. So the premise here is that I log in with a portal that you see on the left-hand side with a username, password, and MFA if I so desire. You can also hook this up to third-party identification management systems like Okta. So any provider that you want. Once you authenticate, you get passed over to the access portal that we see on the right. And what's cool about this is if you have an organization with 20 different AWS accounts, I can scroll down and say, hey, I want to do something inside this account. And then I have a couple of options in terms of I can specify different roles that have been granted to that user. And then I can decide if I want to go into the GUI or if I want to get a set of temporary access keys. And so we do away with the long-term credentials, which is great, and we get temporary access to either the console or access keys. Let's break this down in terms of how it comes together. It actually reminds me of like WMI subscribers if you've ever messed around with Windows. So you have users or groups of users in the top left there, and this is specified as a unique identifier. You'll notice that nothing else in AWS looks like that, so that's gonna come into play in a second. The other piece you get is a permission set, and you can attach policies to this permission set. You can build things in line, and it's basically what can be done. And these two are floating independently of each other. They don't know that each other exist, and you can build as many users and as many permission sets as you want. If you don't do this next step, you're not gonna grant anything. The next step is what's called an assignment. An assignment is made up of a few different portions. The first one is the AWS account you want to grant access to. The second one is the permission set, and the third one is the user or group. I'm gonna flash a bunch of API calls up here. A few different pieces of this. You create the user, you can add that member to a group. You can create permission sets, you can add policies to that. And then finally, you can kind of bind those two things together as a create account assignment. And so if we stop and think about this, if I'm a mature organization, very likely I'm not creating a whole lot of account assignments after I get things situated. Very likely I have groups that I have created these assignments with, and I add users to that group. And so depending on how your organization works and kind of how much of a cowboy your admins are in AWS, maybe create account assignment isn't something that you see very often. So with that said, now we need to figure out how an adversary takes an IAM user and pivots over to one of these SSO users. They do that by creating this user. On the left-hand side, you'll see I've filled this out with totally legit information. And I've created the log, or I've created the user, and then the resulting log is over there on the left. I'm gonna throw some shade at Microsoft. This is the most Azure log that AWS has. It's overly verbose and tells me virtually nothing. All of the information I put in does not make it to the log. So I don't get a username. What I get is a weird, unique identifier up there on the top right, highlighted in green. The other thing that I want to point out is at the very top of that CloudTrail log, you'll notice that this comes from the SSO-directory service. So if you're creating a detection on this, make sure you don't get your IAM create users and your SSO create users mixed up. With that said, great. I'm sure that when this user does things, it's going to have this identifier in it, right? Not quite. So you create this user, it's got this weird identifier, and then if you authenticate and you start doing things with that user, you appear as a traditional ARN. And there's no direct connection between those. So we started digging into it because from an investigation standpoint, I can't have a user create, or I can't have an adversary create an SSO user and then just drop off the map. That's not useful for anyone. So we started looking at the authentication process. And so as you're logging in here and using MFA and creating access keys and sign in, all of these different API calls on the right-hand side kind of pop up in your CloudTrail feed. And so we started digging through those and say, okay, there's gotta be something useful in here linking these two. And luckily we found something. It's the federate log. And we get all the pieces that we need to kind of complete that picture. First, you have principal ID up top there. That is the unique identifier of that user or group. You have the username that was created back on this slide, so HackerMan would appear in that space. And then finally, you have the role name down there at the bottom, along with the AWS account. So if you have all those pieces, down at the very bottom, this is what the ARN will look like. The only thing I don't have, and I haven't figured out how it works, you'll notice that I have kind of a variable string in there. Right after the role name, there's a random string of characters. And if anyone knows how that's generated, I would love to talk with you after this. I don't know, but even then, I've got enough to piece this together and I can bridge that gap. The only other one that I found that I think really helps track that adversary is the get sign-in token. And that's mainly because in the response elements, you'll notice there's an access key. That access key starts with ASIA, which means it's a temporary credential, and this is what they're gonna use in their session. And so maybe you can use that to also track that adversary alongside the ARN there. So you get some options. So to summarize, think about these services, right? Not everyone is using federation tokens. Not everyone is using IAM Identity Center. Maybe you've been sworn off of IAM users. Great, those are awesome detection opportunities. The other thing is look for that cross-account activity, right? Look for where that user identity type is AWS account and make sure you know what account should be reaching into your environment. And then build alerts for when new ones come up. A good way I found to investigate that, because I was working in a client space where I didn't know anyone. I had like one security point of contact, and so I was like, well, I guess I'll just ask you every time a new account shows up. Jira and wikis are a great place to go search those account IDs. Hopefully somebody's documented it somewhere, but that's not always the case. As I said, activity from unused services is really useful, so make sure you have alerts set up for that. And then understand how users get created in your environment. Brian and I are operating at a little bit of a different scale here with multiple client spaces, but I know some of you have environments that are so big they might as well be multiple clients. So this last one is easier said than done, but if you have a standard protocol for things, look for deviations from that. Next recommendation is to limit your blast radius. So build your policies to be more specific. The one on the left here just says you can do any EC2 activity against any resource. That's gonna get you into trouble. right? Especially once you start dealing with the identity side of things, it may be harder and harder to track that adversary. On the right-hand side, not only do I specify that you can only associate an instance profile, so I've specified the API call, but also I've said only against resources that start with this prefix, and I require MFA. So it helps those permissions to keep from getting away from you. As I promised, this is the picture slide. So if you want to take pictures of all the API calls that I talked about, this is the one to do it. But just a quick summary here. We talked about creation of IAM users and access keys. We talked about federation tokens, roles, and then we wrapped it up with SSO. With that said, I want to open it up for questions.